welcome to the lecture on important mathematical functions and its characteristics. So, in the earlier lecture we had the introduction to the financial mathematics, and we also had the concept about the numbers. Now we will be trying to interact and make you aware and basically refresh your knowledge about the different type of mathematical functions which are typically used for the financial mathematics. And in that basically what we see that normally the exponents or exponential functions and the logarithmic functions, they are mostly used when we talk about the financial mathematics. So, we should know something about it, and we will also discuss in brief about the laws which or its characteristics, how they are used, what are the different laws of exponents, what are the different laws of logarithms that we will see here. Now, when we talk about exponents, nothing but the number multiplied by itself, that is exponent. So, suppose 2 is multiplied with itself and to 10 times. So, we tell that 2 raised to the power 10 and 10 is the exponent. So, that is how the exponent is defined. It can be done for any term, like you have 1 plus r, and 1 plus r is multiplied 10 times. So, that will be, so again it is also 10 times if it is done. So, it will be 1 plus r raised to the power 10. So, that this 10 is the exponent, that is how the exponent is defined, and this is very much used in the case of financial transactions or economics, because many a times you need to, so suppose you are talking about the interest, or you are talking about the depreciation, or you are talking about the investment cases. In those cases these exponents are many a times coming. Now, there are many laws for these exponents, and common laws of exponents we must be knowing, but I will just brush up that what are these laws of exponents. Now, in this case when we have the if you have a base, so this is the base and this is the exponent basically. Similarly, you have the base and you have the a and b are the exponent and x is the base. So, x is base and a and b, they are known as exponents. Now, for that there are many rules, like when we define multiply these two quantity, then in that case the exponent is added. So, that we know that this is one of the law of exponent. Similarly, when we are dividing these two numbers xa divided by xb, so in that case the exponent will be subtracted. Similarly, when you are having xa and then that is raised to this b exponent, and then we are telling it is to be x a into b. So, you can have any number like 3 raised to the power 2 and 3 raised to the power 3. So, that will be 3 raised to the power 2 plus 3, that is 5. So, the example is very clear, 3 raised to the power 2 and 3 raised to the power 3. So, it will be 3 raised to the power 2 plus 3. So, 5. So, it will be 9 and it will be 27, it will be 243. So, same thing it is. So, this way the rules are there, and they are used for making these numbers. So, then if you have, so this same thing can be applied for all these formulas, all the laws, like 3 raised to the power 3 divided by 3 raised to the power 5. So, it will be 3 raised to the power 3 minus 5, that is 3 raised to the power minus 2. So, that way 1 by 3 square. So, all these things can be tested. Other laws which are coming, like when you have two different bases, and if you have one exponent, then it can be taken as x raised exponent will be x a and y raised to the power a. So, this way there is another rule. So, that is defined. Then from here you have x by y raised to the power a means x a divided by y raised to the power a. So, this is another law which is obvious. Then you have 1 by x a, this we define as x raised to the power minus a. So, this is also a law of exponent. Then if you are finding the ath root of x, so if you have a x, so it will be nothing but x raised to the power 1 by a. So, that is another law of the exponent. And you have if you have x raised to the power b, and if you want to find the ath root, in that case it becomes x raised to the power b by a. So, this is another rule. So, these are basically the laws of the exponents, and one more is that when you have 0 as exponent, then it becomes equal to 1. So, these typically these exponent laws are used. So, if 0 is the exponent, in that case whatever be the base, so with the 0 as exponent it will be equal to 1. So, these are the normal laws of the exponent. Now, coming to the term known as exponential function. So, you have a function where this exponential term will be used. So, you have exponential function, and here you have a constant a, and it has a variable exponent x. So, that is you have a constant that can have any number, let us say suppose a, and you will have a variable exponent that is x. So, now this x, so a has to be the larger than 0, and it should not be equal to 1. So, if that is 1, in that case its value will be always 1. So, in such a case you have these are the conditions that you have a has to be larger than 0, and it should not be equal to 1. And also you have so basically when we talk about many things in the financial terms like growth rate or so, in those cases these functions are used, and in that case you have basically a dependent variable. So, that basically is expressed. So, you suppose if you have a dependent variable y, so this y they can be expressed. So, suppose something is growing at a certain rate or so. So, if you have one independent variable x, so that can be expressed like a raised to the power x. So, you have one independent variable and this will be depending upon the x. So, that is why y becomes the independent variable, and in that case you have a has to be more than 0, and then a has not to be equal to 1. Now, this is for the growth rate. Basically normally we try to see that such functions normally you will be coming across, and that is how these exponential functions become important in economic decisions. Now, if you look at the values, suppose you take the example of the if you have x value as 1, 2 or 3 or -1 or -2 or -3. Now, in that case if suppose you are taking y as a as 3 by 2. So, y will be now if you can have the value of y. So, this x is basically your independent variable, and if suppose y is 3 by 2 raised to the power x. Now, in that case so a is basically 3 by 2, and in that case you will have values coming up. So, if it is 1 it will be 3 by 2, If it is 2, then it will be 3 by 2 raised to the power 2, so it will be 9 by 4. It will be 3, then in that case it will be 27 by 8. Then if it is minus 1, then it will be reversed and it will become 2 by 3. Similarly, it will be 4 by 9, and similarly you will have 8 by 27. Now what you see that when you have this x value is positive, you have growth of the values like 3 by 2, so its value is 1.5. You come to x raised to the power 2, so in that becomes it 9 by 4, that is your 2.25. So it has increased from 1.5 to 2.25. Similarly, you have 27 by 8 for x equal to 3, so it will be 3.375. So this way there is growth, so that growth functions basically we will be dealing with that. Similarly, you will have in another case the x value may be negative. Now if that becomes the case, so that will be decay value, so there will be decay as x is increased or so. So in that case, if you have y equal to 3 by 2 raised to the power minus x, so here there will be decay. So if you look at 1, it will be 2 by 3. Similarly, you have 4 by 9 and you have 27 by, so it will be 8 by 27. But if this value becomes negative, in that case as you see it will be becoming like 3 by 2, then you have 4 by 9 by 4 and then 27 by 8. So that is how these values will be changing, and you can see that these exponential functions will behave in a different way. If you try to take the its graph, what you see is that if you have this, so this is your suppose you take the example of this y equal to 3 by 2 raised to the power x. Now this value if you look at, so when this x will be 0, so its value will be 1, so at this 1. Now so if it is 0, then in this side you have minus 1, minus 2 or so. So you will have minus 1, minus 2, minus 3, minus 4. Here you have plus 1, plus 2, plus 3 and plus 4. So now when this x exponent value is 0, then you have 1, and now if you have a growth value, now if you look at, so your as the x is increasing, you will have the increase in like this, and it will be decreasing like that. So this is a type of curve which you get in the case of the x as the positive value, and once you go towards the minus, so this will be for 3 by 2 x. When you go for minus x, so in that case you will have this way, and then it will go like this. So it will be 3 by 2 raised to the power minus x. So this way if you look at all these exponential functions, in such cases they will be passing from here. If you have 4 raised to the power x, it will go like this, and it will be going like this, and then it will be coming like this way, it will be moving. So it will be just going, and it will be touching like this, and this will be 4 raised to the power x, and this will be for y 4 raised to the power minus x. So what we see is that when the x is increasing, it is a decay curve, so it is decreasing, and when in this case it is increasing, so that is growth curve and decay curve. They are normally represented by the use of these exponential functions. Now there is another function, that is natural exponential function, which is many a times used. Now when your basically base that value is set to one natural base, then it is known as the natural exponential function, and in that case the base, so it will be e raised to the power x. So this is basically the natural base, and its value is basically fixed, and we know that its value has 2.718 like this. So we know that it's the e value is defined as limit of x tending to infinity and 1 plus 1 by x raised to the power x. So that way you define this e value of e, and when you have this, so that is known as the natural exponential function, and for that natural exponents also there are many laws, and basically you have a constant rate of growth. So this function will be describing the constant continuous growth at some constant rate, and it will be used in many cases like growth of population. Then you have also negative rate of capital growth. All these things I have been seen that they are going and following this exponential function, natural exponential function, and they are used. So they are also used in the case of depreciation of assets or so. Now for the natural exponents also there are many laws, and these laws are like, if you in this case also if you have the exponent, its exponent as 0, then it becomes as 1, and if you take its one exponent, then it becomes as e. So it will be, as we know, that 1 8 2 8, and it will go like this. Then same law of exponent will apply here. So e raised to the power a and e raised to the power b, it will be e a plus b. So these exponents will be summed up. Similarly e a and e raised to the power b, so e a into b, e a by e b, so it will be e a minus b. So these are the typical laws of the exponents which are used in the case of these natural exponential functions, or in fact the exponential functions. Now we will deal with certain other mathematical terms, and one of the term is basically the scientific notations. So when we talk about the scientific notations, so as we know that when we talk about the notation of any number, what we see is normally in a most convenient form we write it as a 10 raised to the power x. So the value a is taken something from 1 to 10, and so it will be varying from 1 to 10. So this value of a will be varying from 1 to 10, and then you are trying to express that number from 10, and then this will be the exponent. So that way we try to, suppose you have 132. Now this can be represented as you have 1.32, and then since we are taking the decimal towards the left, so you will have the exponent 2 to be used, 10 raised to the power 2. So that way we use these exponents. So depending upon how you are moving the decimal, on which side you are moving the decimal, if you are moving decimal towards left, then you will have the use of positive exponent, and if you have the movement towards the right, in that case you will be using the exponent as negative 1. So suppose you have 4 5 2 3 8 similarly. So now you are having the decimal point here. So this decimal will be, now in this number is 45238.0 basically. Now decimal is moved to 1 2 3 4 point. So it will be 4.5238, and then it will be, since we are moving to 4 places towards the left, so you are going to this exponent as 4 as the positive value. So that way we represent. Now on the other hand, if you have number like 0.02568, now in this case to represent it scientifically in the scientific notation terms, the decimal this a, for when we try to define a, it has to be between 1 and 10. So, you have to move the decimal towards the right. So, you are moving the right to 2 places. So, then it becomes 2.5. So, in that case, so you will have 2.568, and since you are moving towards right, this decimal place to 2 places towards the right. So, you will have the raised to the power minus 2. So, this way what we do is that we normally represent these decimal these scientific notations by moving the decimal points towards left or towards the right. Now, next as we discussed, so we have discussed about in length about the exponents. Now, we will discuss about the logarithmic functions and concept of log. Now, so we must have the idea of these logarithm. Now, when we are discussing these logarithms, so as you know that many a times when we get a number by raising the exponent to something, suppose you are getting 8 by raising 2 raised to the power 3, that is 8. So, basically if you try to have the log of 8 and base is 2, so that will be equal to 3. So, how many times you have multiplied the same number, so to get certain number. So, if you are taking the log of that number with this base, the exponent which are used, that will be the logarithm value. So that is how you so basically it is nothing but the special form of the exponent itself. So, normal practice is to have either 10 as a base or the natural log taking e as the base, and suppose you want to have the log of 100. So, as you know that 10 has to be put in. So, 10 raised to the power, suppose the exponent if it is 2, then only it is 100. So, if you take log of 100 and base is 10, in that case its value is 2. So, that is how the log is used, and the value, this exponent value need not be always a whole number. So, it may be something like a fraction or a decimal point. So, that value, the log value will be also a decimal value. So, if you take the log of suppose 15. So, how can you find it? Now, if you see that if you take the 10, if you have the exponent as 1.176, then it becomes 15. So, since this exponent is 1.176 and that relates, so if the base is 10, in that case it will be 1.176. So, this is the concept of the log. So, it is basically special kind of exponent formula only is being utilized to have the value of these logarithms. Then you have also natural logarithm. So, in that base is e. So, in that case we call it as ln. So, in this case you have the base as e, and or you also call it as log e. So, you will have any number. Now, what we see is that this number that 2.71828 and all that. Now, that number has to be raised to any so that you get a particular number. Suppose you want to have the value of ln 50, it means the 2.71828. Now, this is to be some exponent should be there such that this becomes equal to 50. So, this x is the value of this ln 50. So, if you try to see, you will see that it will be something like 3.912. So, this x will be this. So, you can write ln 50 is 3.912. So, this is how the concept of log is normally used, and in financial statistics many a times you need to know that what should be the exponent by which it has to be the exponent value to be used, so that it becomes equal to the desired value which you want. In those cases this log will be used. Now, the contrary to this, the opposite will be anti-log. So, anti-log, if you have, you can, similar to log, you have the use of anti-log also, and there are rules of logarithm also, similar to what we have seen the laws for the exponents, and in the log also, if you have log x plus log y, it will be log xy. Similarly, if you have log x minus log y, it will be log xy, log x by y. Then if you have log x raised to the power a, in that case this a comes further here, so it will be a into log x. So this is the law of the log. Similarly, if you have log and ath root of x, in that case x raised to the power 1 by a, so the 1 by a will come to this side, so you can write this as log x raised to the power 1 by a, so it will be 1 by a log x. Then also if you find the log 1, it will be always 0, because any number, so if you take 10 as a base or e as a base, its power exponent 0 when it is taken, it is equal to 1. So log of 1 will be always 0. Now you have also the logarithmic functions, and these logarithmic functions are also very much used in the case of these financial analysis. And if you try to find the function of the logarithm, how it looks like, so if you try to draw, then a function something like this function is there, or this function is there. So this will be a logarithmic function. So you have this x and y, and this is the y equal to log 5x. Or so basically what is there, how you define this one. Basically 5 raised to the power y is nothing but it is x. Basically from here the function is 5 raised to the power y is basically x. Similarly log, this function will be y equal to log 1 by 5x. So basically here x will be 1 by 5 raised to the power y. So this way these logarithmic functions you can see that it will be used at many places. You will have -1, -2, this is going like minus, and this is you have plus. So these are the different type of logarithmic functions which are used, and these have this such kind of characteristics which are very much clear that they will be used in many cases as we study this course. I hope you have understood this, and you can have the practice of these mathematical functions, so that we can discuss more about the mathematical terms in our next lecture. Thank you very much.